Everybody. So we are doing a fun simulcast with Hans over at Hans C. Nelson. Fantastic guy. And we've got a very special guest today, my good friend Ken from Michigan, who spent 30 years working in airbag electronics and knows a thing or two. You may have seen some of his fantastic posts yesterday on X. I know I did, and I reposted them because he got to walk the line. And unlike most of us, he got to understand what he was looking at. So we're very grateful to have him on. And what we're going to do is take a look at the video that came out today with Sandy Munro and a bunch of the engineers from the engineering team to see if we can dive deeper into what we actually saw. Let's have some fun.
Hey, everybody. I'd like to thank Ford and that's because
help them bring
we're at the Cybertruck heaven, I guess would be the best way to put it. We're at the main building on the Gigafactory, and today we're going to take a deep dive into what's going on inside of the brand new Cybertruck. Now, I could try and introduce everybody, but we know that Sandy's not good at that. So, Lars, can you kick it off?
Yeah, hi everyone, I'm Lars Moravi. I'm the head of vehicle engineering. I do most of the normal car parts on this truck.
I'm Franz von Holzhausen, head of design. Design Cybertruck, crashed a window, and make these guys' lives very hard.
Drew Baglino, I lead powertrain and energy at Tesla. So the batteries, drive units, the power electronics in the trunk, those are my baby.
Hi, my name is Pete Bannon. I lead the low voltage electronics and the autopilot hardware team. So my team designed all the low voltage controllers and the cameras and the displays and lots of little stuff. And
David Lau, run the vehicle software team here, work with pretty much all these guys and help them bring all their great hardware to life with software.
You know what? I'd like to start with you because Pete, you have the thing that I know the least about, and I have to ask a question that I'm sure will be controversial. Why is it that you're not selling your software to all the other jamokes that are out there that have got 210 little boxes that each have their own software created by somebody else, and then they try and, communicate with each other? Have you ever considered, or is anything in the works to consider maybe just selling Tesla's complete software package instead of having these guys kind of do workarounds?
All the OEMs and tier one suppliers.
Yeah.
I would say that hasn't really been a focus for us. Like we've been super focused on integrating as much functionality as possible with software and also with all of the hardware that we've brought in-house at Tesla. And we really feel like that integration is creates so many capabilities that allow us to deliver the product that we have right now. And so it's not really any one thing. It's not like, oh, well, because we did the software.
So I think Ken can speak to this. Integration is not easy. It's not like you just buy software and it works. Is that fair?
That's very fair. A lot of the times, it's a back and forth reaction between the OEM and the supplier. I worked on tier one, so we were always talking back and forth. They write a spec. A lot of things weren't detailed enough, so we had to ask more questions. So it is a very difficult thing.
And so what you get is a story I saw a couple years ago was a guy who posted on Reddit whose background looked consistent with his story, which was when Tesla came out with the light show, the holiday light show, he worked at Kia or Hyundai or somewhere like that, and they came to his department and said, we want that. What's it going to take? And he said, well, first we have to go and validate all the parts, all the systems. We have to write it. Then we have to test it. Then we have to revalidate through all the suppliers. We have to send out requests for bid on every aspect of this. The answer is it will cost us $30 million and take 3 years, and it might not work. We're not going to do it. Does that sound consistent with what you know from having worked a career in the automotive industry.
Absolutely. The OEMs are the tier one suppliers are very reluctant to make any kind of changes. So Tesla is more ad hoc. You know, let's change it. Let's do this. Let's do that. And they just do it on their own small team because small teams are much more efficient. Even
And
one
then-
person.
Would that
Go
tier
ahead.
one supplier, do they have their own software team in house, or is that further subbed out to a tier two supplier so that any changes to the software also has to go through an additional layer, even besides just the tier one?
No, well, it could be different, but like in my field of airbag electronics, we were the software people. But remember that we also farmed out some coding skills to third-party companies or even low-cost zones areas. So that took a lot of extra time, whether it was India or China or wherever.
Okay, back to the video.
For this part, that's what makes the car great. It's really because we've been able to take a look at the whole system and say, like, how are we going to make all these pieces work together rather than letting them fight with each other the way they normally do in like a traditional automotive.
It's a tight integration, right? Like it'd be hard to just peel the software off anyway.
That's right.
It's really tightly coupled to the
Yeah.
hardware design.
I will say though, we also have been like increasingly focused on enabling an ecosystem of software developers, like third-party mobile app developers. We just released an API that allows third-party mobile app developers to develop mobile apps against.
Well, maybe
our servers and
that
vehicles.
might be the answer then. Maybe what you could do is work with the supply communities, and somehow the OEMs could figure it out. Certainly, the guy that needs to figure it out the most is that German company that starts with a V. I can't remember, but anyways, they seem to be. I just heard a few minutes ago that they're going to eliminate 40% of their production.
Wow.
Yeah, that's wow. And the other thing I heard was, guess what? The German government doesn't know how they're going to be able to make that happen because of all the rules and regulations that they've got. So, so who knows? You may be, getting into a sales role, got to eat shrimp, wear ties and stuff like that.
Yeah, I don't remember the last time I wore a tie.
Yeah.
Certainly not around here.
Well, let me throw one out then on the 48-volt system. As you may have heard, when we got the Model Y, the second one, we started tearing it apart. I was very disappointed that it didn't have. I thought it was going to have a 48-volt system, and there it was not there. So
Not for lack of trying.
not for lack of trying.
No, we didn't really try. I mean, part of the problem is that we have a tremendous amount of manufacturing capacity in place to build 12-volt things for Model Y, and we don't really want to rebuy all that capacity and retool it for 48 volts. So 48 volts is very much a forward-going thing as we redesign new cars and introduce new cars, or we have to increase capacity. Then that's an opportunity, since we have to go buy new tooling anyway, to switch to 48 volts.
Yeah.
And that's sort of true for a lot of the capabilities across the car.
So how much of the system did you have to make? I'm assuming connectors, sensors. What else?
Oh, all the motors had to be
all-
redone.
Yeah.
A lot of the, there's even little simple things like how are you going to jump the car? So we had to figure out how to do a 48-volt car. And so there's a really nice switch tank converter circuit that allows us to detect whether you've attached a 12-volt thing and boost it to 48, or whether you've attached a 48-volt thing and then just jump the car straight away. So
Let's go ahead and pause it there. So this is why I'm so glad we're able to get Ken on as the actual automotive electrical engineering expert, because these are all things that even those of us who've been following the Cybertruck very, very closely, following Tesla very, very closely, wouldn't have considered. I didn't consider these things. This is kind of a big deal. All the little things. Name some parts in the car that they don't have to change. We're talking the window motors have to change. The blinkers, of course, that's easier. It's LED. It's going to be a little more voltage agnostic. But the airbags, I assume those are triggered 12 volt today, and they need to be changed too.
That's true. It'd probably be a lot easier actually for the airbags because we had internal capacitors that supplied the airbag to deploy in cases when your battery is severed. So, and we bumped that up with a boost inverter, a boost supply to, I don't know, somewhere around upper 20 volts. So this would actually be a, I think it's called a buck down. I remember I'm a software guy, not so much a hardware guy. I did some hardware in my career, but yeah, so you don't have to buck it down, or you'd be bucking it down instead, boosting it up. So it's a little easier.
And I mean, it's everything. It's the infotainment. It's, I assume the hardware that runs FSD is not 48 volt inherently.
I'm sure it was 12 volt.
The cameras, it's absolutely everything, which is why no manufacturer has done it.
But one thing you have to remember, and he says this in a couple of seconds, even though all the devices run on 12 volts right now, that the components such as the microprocessor, they run at 0.7 volts,
right,
1.3 volts, 3.3 volts, 5 volts. You know, it's a whole span of things. So again, it's easier to reduce the voltage than to buck it up, boost it up.
And a question I've been fielding a lot on X and in my YouTube comments is, does this mean we're going to immediately see a 48 volt transition in 3 and Y? And the answer I'm hearing to that is no. It's too many pieces.
Yep.
Mm-hmm.
And especially,
and I don't mean
if
physical pieces. I mean the integration, all of it. Go ahead.
Yeah. Thinking about Jeff Lutz would be the right person to ask this question of, but, you know, to have capacity for not only hundreds of thousands of vehicles, but, you know, millions of vehicles, even if you could get all the design and the integration correct, that doesn't mean that you can instantly ramp up a supply base that can give you all of those new components, because you're not just reusing the same components. And, you know, and I think it makes sense why Pete was saying that they didn't do that for the Ys, because they've already got the supply base built out for the Model 3, and they just want to ramp that Model 3 supply base up further, and they want to reuse all those parts for the Model Y. And so they didn't want to have two different supply bases, one for the Model Y and one for the Model 3, and then also have, you know, an inability to use parts from the Model Y in the Model 3, which creates more complexity in the actual manufacturing plant. You know, you've got different parts. Whereas, you know, if you have the same supply base, you can use the same parts across the factory. You don't have to handle having storage in the factory for one versus the other, getting any mix up. That, you know, everything is just a lot simpler if you can continue to use that. And so, you know, it makes a lot of sense from that perspective why they didn't go to this 48 volts yet. But it also makes a lot of sense now that with the Cybertruck, you know, it's not a shared platform with anything else yet. But I think a lot of the things that they're doing for the Cybertruck is kind of getting the supply base primed and ready to begin ramping it, because obviously a lot of the technology that's used here in the Cybertruck is what we would expect to see here shortly as they ramp up the next gen platform.
And then they're testing it out on a lower volume so that they can get it right. Mm-hmm.
Exactly.
Okay.
There's a lot of little things like that that go into making 48 volts work smoothly.
Seeing as we're still on that, I had a look at something that made me caused me to think about things. Inside EV put out an article and showed a couple of blueprints, crude blueprints of patents that look a lot like we used to call multiplexing, but it says basically that maybe you've solved the problem of gigantic amounts of wire. Is that correct?
This episode of Munro Live is brought to you by the 3-Dimensional Services Group.
Hey, boys and girls, I'm here with Dan.
Are available to
Meaning the space bridge.
Well, I mean, 48 volts doesn't reduce the number of wires.
Well,
it just
let me rephrase it. It enables one other thing. We used to call it either communication or whatever over power. Is that? Are you
no, we looked at that really hard, but the power system is extremely noisy, and you can make it work, but it's hard. And so the cost of 2 more conductors to have a really clean communication system it's just worth it in our minds.
Although we are doing some interesting things with communication on the truck.
Oh yeah. So we have switched to Ether loop. So we have a gigabit Ethernet loop in the car that connects all of the high-speed controllers together. It's bidirectional for redundancy, and that's turned out really well. So the number of wires that go across the car has been reduced dramatically, even though the number of endpoints went up. So the total mass of wires is way down, and the average length of wires is significantly shorter because
so
they're
Then we
I
can put
made
the
a guess.
endpoints where the controllers
Yeah,
are,
right.
rather than putting the endpoints wiring,
On
like
the-
routing a bunch of wiring to an
Yeah.
endpoint that has to connect to a controller halfway across
Yeah.
the car.
Yeah.
so like audio flows around on Ethernet and gets distributed to speakers all around the car. So then there's no audio overlay for wires.
And,
So
and
in
while-
one of my YouTube things, I said that if you could do, and I didn't think of maybe an Ethernet loop, but one of the things that I suggested was that could probably eliminate about 80% of the weight associated with communication wires. How close did I come?
I don't actually know that number, but
What? Oh my God!
but overall, between Etherloop and 48 volts, the mass is down significantly. Yeah, I don't know. It's half.
Half.
We'll have to follow up for you.
Yeah, we'll double check our homework.
Okay, well, half is still quite a bit. Half, that's got to be at least 15 kilos or something like that.
I mean,
Yeah.
the Cybertruck is a lot bigger, so it's sort of like on a per unit basis. You have to compare it to be fair. Right?
Yeah, there's.
Yeah.
I wrote the numbers. I have a cheat sheet
So do
Because
I.
because I didn't remember all.
Fortunately,
the
I
numbers.
haven't had to reach for it yet. These are off the top of my head, but
Yeah.
oh my God!
So
Really, you got small printing.
So Model 3 has 273 endpoints, and Cybertruck has 368, so 50% more
that's a
endpoints.
lot more connections. Yeah.
And the number of wires that go across the car went from 490 to 155, so a 68%
That's two. Wow,
reduction.
that's three quarters.
High-powered harness mass went down by 84%
84%.
for high-powered loads. Yeah,
Really?
so that helped a lot.
I mean, yeah, like
Well, that's a hell of a big
the steering
number.
system, right, on a 12 volt. When you get a thing this big, it's got to have like, 18 kilonewtons of rack force.
Yeah.
So the motor, like the wires are like,
Yeah.
2 4-gauge wires, and with the 48 volt motors, they're significantly smaller.
Yeah, and I think we found that, like, when we were looking into whether this would be worthwhile or not, 48 volts, that is, we looked at, okay, it's going to be really hard to convert all of the loads, but what we found was that I think 83% of the power, peak power, comes from 13% of the loads.
Devices. Yeah.
So, like, we attack those 13%, and we get a huge benefit in terms of sizing for those.
And also, it was Pete's not maybe fully taking credit for it, but it was the 48 volt was not just a voltage choice, but also a how do we logically distribute the functions, and what are the vehicle controllers doing? How does the power conversion happen? Because eventually, a lot of these microcontrollers, they're running at 0.7 volts or 1.3 volts. So you have to do power conversion from 48 anyway. But so it's this thoughtful lumping of functionality so that you can use the ether loop plus the 48 volts to have a minimum number of controllers that do the most amount of work. And that also is a virtuous circle, because like the more stuff you get into one controller, the more like value you get out of that 48 volt connection, right?
Another
Let's go ahead and pause it
unexpected
there.
benefit of Etherloop.
So one thing I did the other day was some math to look at how big of a deal is 48 volt, and not just for Tesla, but for everyone. And if there are, at one point it was 80 million new cars a year. Right now it's a bit less. It's in the high 60s worldwide. If all of them switched to 48 volt, we would be looking at a reduction of about 80% of the copper needed per car, which means 1.3 million tons less copper required annually. Copper is recyclable, and it is recycled, but we're not seeing that loop closing because the demands exceed the supply of secondhand copper, and secondhand copper is not that much cheaper than new copper, so it's just as good. It's elemental. It recycles perfectly, but what we're seeing is this is think of the emissions reduction by not mining 1.3 million tons of copper. Just giving out this engineering report and pushing other manufacturers to do the thing that they all agree they needed to do 30 years ago is going to be the biggest net benefit environmentally that Elon has done to date, I would argue. Thoughts on that?
Yeah, it's a lot of copper, and especially as EVs ramp up, there is more copper that's needed in other areas. But I think that overall, I mean, I'd love to see the breakdown. I'll bet you if you removed that much copper in the wiring harness, but then you added in the extra copper that's being used in the motors in various places, that you would still come out at net overall reduction in copper use.
Tough to say. There's a lot of copper in those motors.
Yeah.
Tough to say. But we're
Or
going
maybe
electric
aluminum.
anyway. Or maybe aluminum. Why? How so?
Didn't Sandy? I'm not a motor expert or anything, but I remember Sandy was saying that when he was showing the hairpin design, some manufacturers I think are using aluminum as well as copper. I don't know.
Interesting.
Take that with a grain of salt.
Interesting.
But all the
right.
that short period of time, there was a piece of knowledge every single second almost from what they were saying. It's very densely packed knowledge in this.
One of the things that I took away. Oh, go for it, Brian.
No, I was just going to say I was surprised that the communication system wasn't on the power lines, that it was too noisy for them to use. But the communication lines are very, very thin.
Yeah, if you've ever seen Ethernet, it's very, what is it? Maybe
Delicate.
28 gauge wire, 30, and you don't need much power. And see, that's the problem. If you put it over power, which you can send signals over power, they'd be swamped by all the electrical noise from the motors because they're very noisy. That's why we don't have AM radios in electric vehicles typically. And then that would reduce the speed that theoretically would be possible. So you'd be giving up to gain,
When he was saying that the amount of power needed to move that steering system, that steer by wire in something this powerful, could be 2 gauge wire. Ken, can you tell us how thick a 2 gauge wire is?
Yeah. Maybe.
Yeah.
It's
It's half an inch.
Right. Even mild hybrids, they used a combination system. They had a 48-volt system just dedicated to the traction motor in a hybrid. So that's why, because otherwise the wires would be, huge. Remember, that requires a lot more current on a traction motor.
Yeah, but this is a very powerful motor, and they were even saying this will allow for when you put a winch on your Cybertruck, the motor will be significantly smaller because it's running 48 volt, and it won't need a converter.
Hopefully, Tesla comes out with winches.
Yeah,
I don't know if they're available right now.
Doesn't seem
One of
so.
the things that I took away from their talk about the wiring harnesses, you mentioned it was, a significant increase in the overall number of endpoints, but then it was a reduction in the total amount of wiring. And so I think what that means, and this is just my speculation, that they are actually introducing a lot of serial connections. So traditional wiring harnesses are made with a lot of parallel wires that are all going, it's like one big harness that's got a whole bunch of wires that are all going to different points. And every wire has one starting point and one end point. And here what they're doing is they're actually chaining together a number in that Ethernet loop. They'll go from one device with a wire and it'll go to the next device. And then from that device on to the next device. And so they're interrupting, like, at each module, there's a whole bunch of stuff that comes in and then a whole bunch of stuff that goes out. And so it's fewer wires total, but more starts and stops at all the microcontrollers along the way. But it's then just kind of one train that would stop at each station as it goes.
This gets into the point of the topology has changed, right? And Larry Goldberg, he had a diagram when he was being interviewed by a couple other gentlemen, and So yeah, it won't go cross car like they were saying as much, but now you have more nodes and probably localized nodes to get closer to that unboxed production technique, because you want to have the microprocessor closer to the area that it's going to be controlling, and then you can go over LIN or CAN to communicate to the more locally positioned microcontrollers to do other things like sensors and things like that.
What is LIN for the viewers and versus
LIN
CAN?
is a slow communication. I think it's based off of your old telephone modems. Modems used to run at like 9600 baud. I think that's about the speed of LIN. It's mostly meant for very simple communications and very simple communications, short communications. Maybe just tell me what the temperature is, and tell me. It keeps on asking that, and it's very fast.
Probably something
very
like
very long, but takes a lot less time.
Yeah, probably something for reads on like sensors versus actually controlling something that is
Right. Position of this
an
motor, temperature
actuator.
here, things like that. Is the switch closed?
Mm-hmm. Gotcha.
Yeah, that's only a bit.
Was just debuggability of the car, because all the data for everything in the car goes over one communication link. You can connect your laptop to it and see everything, and it's all synchronized in time, so you can see exactly what the car is doing. Whereas in the past there were multiple CAN buses, and you'd have to, you'd be connected to one CAN bus and go, missed it, go to a different CAN bus.
And furthermore, like the amount of like debug information you could put on a 500 kilobit like theoretical peak bandwidth CAN bus is 200 times less than what you can put on a gigabit.
So let me ask a dumb question. Like I say, I'm not a software guy, but with this kind of system, does that drop the number of lines of code that you're going to need, or
drop the number of lines of code?
I mean, there's at least on the communication side, it
is a much more like homogeneous system.
It's homogeneous. That's what it is.
In that, we've got a very small number of, let's say, like Ethernet, like basically little routers that then fan out to smaller CAN buses. For particular like localized purposes. I wouldn't say it necessarily reduces the amount of code, but it sure makes it easier to develop on and debug, because you've got so much more visibility. And what you basically have at that point is a software-defined network. Like it's not like a statically defined CAN bus. It's like completely software-defined. We can change the way messages route and who they go to, and listens to them completely in software on the fly.
Yeah. It's also like, even though it's Ethernet in name, but it's not like Ethernet protocol in practice, because like regular Ethernet has randomness to it, and packets can be dropped and stuff. So the way we use Ethernet as a transport is quite fixed and planned, and it's time sliced, so it actually looks a little bit more like a token ring network in that regard.
Yeah, it's basically a TDMA network, which means that like each like Pete said, it's time sliced and like in a highly deterministic way. So we are confident, similar to the way you are with a CAN bus, that the behavior of the network is going to be determined.
You don't have variable latency.
We're seeing synchronization at a microsecond.
I was going to ask about was latency. Did this? You already answered the question, I think, but this improves latency. You should be able to get communication done faster.
Millisecond scale latency and microsecond scale synchronization.
Yeah, microseconds.
Because we also have audio flowing over that same network, and bidirectionally too, because when we're doing active road noise cancellation, we've got data coming in from microphones and other.
Yes. Active noise cancellation.
Lots of tidbits there.
Yeah, I saw you put your thumb up, Ken. Did you want to jump in and say something about
what he's saying right now is something we didn't know, right? That there probably is, if not already rolled out, there's going to be active noise, road cancellation noise in these cars, just like they have in SNX, but it's going to be more effective because SNX doesn't have this Ethernet ring. Mhm.
Hmm.
And what you were saying before about the deterministic effects of this, it's very important to know when a message comes across. That makes things so much easier rather than the variability of messages. You want to have it, right on
On a
tick,
clock.
on a clock, and that's very important. And like you said, debugging. Oh my gosh, having all that information in debug, whereas you used to have multiple cans. I mean, I ran into that too. You had multiple cans, like, oh, when did this message come in compared to this message, and makes things so much easier. Debugging is, of course, a huge benefit.
One of the things that stood out to me in all of this is, in a past life, I did work in a manufacturing field where we had a lot of standards that we had to abide by, whether they were IEEE or any number of things. And what Tesla's doing here is really all outside of the scope of current standards for the automotive industry and the supply base. And I am hoping that actually the work that they're pioneering right now, they can transfer to the supply base, and new standards can be written on how to actually handle the, because if they're not using actual standard Ethernet, if they're doing the communications protocol in a different way, then that is something that should be standardized across automotive suppliers moving forward in the future. And it's, information that Tesla has and they can share with the industry, because, it would take another company quite a bit of R&D. There's also the politics of trying to get everyone together to collaborate, to come up with something. And if there's something that's already out there and it already works, it makes it a lot easier for other people to just adopt it, because you don't have to prove that this is going to be something that everyone can do if it's already being done.
Mm-hmm. That's a big problem, because there's that not invented here syndrome that we always have. One OEM from another, in CAN, the messages were not even close. Like if you had a system for a Ford vehicle or a GM vehicle, the messages would be completely different. And well, over CAN, there's the CAN standardization document that tells you just how to send messages, but not how to structure the messages. And like Tesla was saying, or I forgot who it was on the stage, they were sending messages via Ethernet, but I believe I read someplace else that it's CAN over Ethernet. So it's maybe a slight hybrid. They don't want to switch everything, because if you think about it, they're going to have to change their complete software stack. But if we can just retain that message structure from the old CAN messages and just transport it over internet, the Ethernet.
Yeah, the gigabit Ethernet.
Yeah, then that might make the transition a little bit easier. But yeah, standardization would be good, but I don't know how well that's going to work.
Okay.
Sensors that then has to get processed by an algorithm centrally and then fan back out to the speakers to actively cancel noise. So that synchronization and latency is hugely important.
But I will tell you, I was one of those people, love it, hate it. When I saw that thing come up, boom, I was on board immediately. To me, I mean, I've seen enough roundy cars. I worked on the very first one. I worked on the Taurus. And it used to be that you got two bricks, clunk, clunk, and there's your car. And that was it. And then the Taurus came out, and I was there when Henry the Deuce took the first look at it. It's crap. You're putting the company completely out of business. And when I saw this, everything's roundy. Everything is kind of like the same jelly bean. And this one here just totally blew me away. I was very, very impressed.
What was a unique opportunity to have a vehicle that really wanted to be tough on the outside, to create an exoskeleton that made the form actually be a result of the function. So I think if we do this for another vehicle and we're not honest about why we're putting the toughness and the stainless steel that drives basically the form, you can only bend the steel in one direction. And it's much less of it's more of a style thing this is really, you know, a through and through kind of design solution based on what you can and can't do with the materials. That makes
Well,
sense.
the material is one of the questions that I do have, and seeing as we're sitting in front of it, I might as well ask it. Okay, so true stainless steel starts at about 316. What is this one here?
I
That
mean,
30 whatever
yeah,
XX.
it's a you know, if you look at 316 or 304, you have different levels of, you know, cobalt and nickel to change the various parameters of it. The reason we called it 30X, we actually just changed it. We call it HFS now, hard freaking stainless.
Ah, very good. Yeah, I love it.
And the reason is it's like it's in between all of these because we had to balance the corrosion toughness, some of the lower grade alloys with the ductility of the higher grade alloys. And so the balance was really, as you know, stainless isn't stainless. It rusts.
Yeah.
And so we had to make it super rust, you know, corrosion preventative because there's nothing on it. And so we balanced that, and then we added a little more ductility because once you roll it full hard, you really can't bend it that much.
Just so that people understand, ductility is how easy it is to bend something. And I'll share a little bit more about the material science of the stainless steel that we're talking about there. But as we go through, just remember that.
And if you notice, I had to rewind it a couple times to hear what Franz was saying about that, and I have to do it a couple more times too. Is he kind of saying that the next gen vehicle may or may not have this stainless steel if it doesn't fit that function? So I don't know exactly what he's trying to say. Just that they had to have the exoskeleton on the Cybertruck because that was what the function was. They want toughness on the outside. So what's going to happen on the next gen vehicle?
Do you have thoughts on that?
I have thoughts. There are, I made a video a while back. I think I made the video. I'm pretty sure I did. If not, I really thought about it. No, I'm pretty sure I did. Looking at all the different ways you could make a car that doesn't have paint. And it could be plastic like the Saturn. It could be carbon fiber. I think that's too fiddly of a solution. You could just do aluminum and let it pit a little bit. There are a bunch of ways to do it. But in terms of sheer simplicity, I made a joke. A lot of times I make jokes that turn out to have a little more plausibility to them. You could vacuum form the whole shell out of a single piece of composite plastic and then just cut the holes. We know they don't want to paint. Paint's expensive. High volume paint shops can be $1 billion if you want to get into something high volume. And not just that, but they add a lot of complexity, and they add 24 hours from the time in the door to out the door because the paint has to cure before you can work it. Then you've got to inventory which doors go to which chassis. It's a lot of extra steps, and if they could avoid it, they will. Somebody had told me that, and it might have been about this video, but I don't recall, where they said they were under a very clear impression that the next gen will not be stainless. And I think that that's very likely because stainless requires nickel, and at 2 to 4 million cars a year, you're running out of the global supply of nickel at that point. So, but I think there are other ways to get a paint-free experience with sufficient strength.
One of the things that we've heard, Sandy and Corey have both talked about that, this is not a quote unquote exoskeleton. And when they say exoskeleton, what they're talking about is like a monocoque structure, like airplanes used to be built with a frame and then kind of a skin on top of it. And then they went to this thing where the actual skin was the structure. And while the Cybertruck, you can see it does have, there's a skeleton there. They've got their castings. They've got some inner structure, that door ring that they've got, all of that. So there is kind of an inner skeleton. It's not a pure monocoque design. When Franz talks about an exoskeleton, remember, he's not an engineer. And what he said, if you go back and listen to those things, he said that we want to put the hardness on the outside. So instead of building a door where you do have high strength steel inner frame that then has a soft metal sheet that's put on top of it that creates the shape. So that door, it's a combination of form and structure. And what Franz is talking about is, okay, we want actually the structure and the form to be the same thing. And then we put the soft metal on the inside to contour it and make it fit to the inner structure. And then obviously they do actually use a lot of the stainless steel throughout the thing to enhance the overall structure of the vehicle in its stiffness so that it doesn't twist from side to side, front to back, all these things. Having those big panels of stainless steel actually add to that. And so it's not something where the stainless steel is the entire structure of the vehicle, but you're putting the structure part, the hard part, the strong part on the outside of the vehicle instead of on the inside of the vehicle. And that is one of the things that drives a lot of these design decisions.
One thing Ken caught yesterday, he posted a picture. If you guys haven't seen, at Utah Temp, Ken was at the factory for the cyber delivery. He walked the line, he took a lot of pictures, and he shared his insights on X with us. And there's some good stuff. One of the things he noticed was a bin of trim pieces that go above the door. They just clip on. Those are not structural. Those are pretty.
You can even see the way they're connected on that crash vehicle that they had. And just to tell you, Lars actually took some time and talked to me. So we walked over to that crash vehicle and he was showing me about how, for instance, Tesla is the only company that does crash tests, front crash tests with the recovery hooks on. I didn't know that, because they do break away in that one position. Whereas other OEMs will not do the crash tests with them, probably because it would be detrimental. That you don't want to see that result. But something he mentioned is that those fender panels, which are stainless steel, actually absorb about 17% of the frontal impact force. So that's where that function comes in.
And I did have a lengthy discussion with Corey at Monroe while he was still there last summer when I went to the Michigan event in Muskegon where I met Ken. And I said, I got to nail you down on it. Is it an exoskeleton or not? And what he determined is it's a hybrid, because if you have just the castings in the battery and the occupant home, no stainless on it yet, it still has structure. Does it have as much as when they add the stainless? No, it gets significantly more. So it is both things. But yeah.
Oh, and the doors. Lars also mentioned that they took all the structure out of the inside of the doors so that it's all on the exoskeleton. So it's hollow. And I said to him, oh, hey, that makes a perfect situation where you can put pressure sensors for side crash impacts in that door, because acts as like a tin can, so you can sense it easier, because side crashes are very fast.
Yeah.
Without
so is this
cracking it.
austenitic? Let me
No,
ask.
it's not.
It's not.
Yeah.
I don't see any bruises. So
No.
you're not making it in a press brake.
No.
Is this up? Here we go.
Yeah.
I'll take you out there. I'll
Hang
show
on a
you.
second.
Yeah.
Okay, so let's see. Okay, so how would you classify this
The
bending
forming
operation?
process?
Yes,
We
forming.
call it air bending.
Air bending.
Yeah, and so basically it looks like a press brake, but we're shooting high pressure air on a bearing that's floating the steel. So as the brake moves up and bends it,
So you're doing it cold?
yeah, we're doing cold.
Oh, all right.
See?
That's wrong.
I know.
And
Rare,
it just
a rare
float,
moment.
it just
A rare
floats.
moment.
It
No,
float-
I'm wrong a lot. Just ask any of my people. They'll tell you.
It floats the air, right? So
Yeah.
and then you get that cushion of like a air hockey table almost underneath it. It's just so you don't get the bruises on it. We don't see that orange peel or that mark from the brake. And then we have full. It's all computer controlled, right? So we have full. You get some spring back, and then we can come back and
Do a double
redo
bend.
it if we need to. So that's why we get the precision. And then you dial that in, and you get one batch of steel, it works fine. Maybe the next batch we have to readjust a little, but the computers do that for us.
Here's a tip.
Yeah.
We don't have a purchasing people here right now, but purchasing was always the guys that buggered me up when I was trying to stamp anything, because I got a sale, and the next batch of stainless steel isn't the same as the other one. So the other one is
This is specific heats for us, man. Like no one else is buying this.
Oh, really? Well, then that's cool. That actually is favorable to the guys on the floor.
So there's a lot of really interesting information there, especially for me, because this is one of the things that I was the most curious about, is how are they actually, the way that the Cybertruck looks obviously is unique. No one else is making cars like this. And so this is going to be one of those things that, this is new process, this is new material. They not only have to figure out how they're going to make it, but then they also have to, going back to the supply chain thing, how they can ramp up a supply of material. We heard Lars there say that they're the only ones that are getting this, and this HFS. I'm curious, when they first started talking about HFS, I was wondering if this is actually distinct from the 30X cold roll steel that they are using for the Starship. In my mind, it would make sense if there's some differences in what it is that they're trying to do with the Cybertruck versus what they're trying to do with the Starship, because obviously in the Starship we don't see these clean bent panels anywhere, and that manufacturing process has a lot of different attributes to it that you don't see in the Starship, that you may actually want to make accommodations for in the actual alloy that you're using. And so I could definitely see that this HFS is a modification. It's based on the same 30X cold roll steel that they're using over at SpaceX. But I wouldn't be surprised if it's somewhat different. Also on the, the environment that it's going to be operating in, instead of going to space and back and dealing with all of the heating and cooling and transonic regimes that the Starship is going through, it's going to be exposed to a lot more salt. It's going to be exposed to a lot more acid, a lot more cold environments with snow, not necessarily cryogenic. And so all of those things make it a little bit different. And so to hear him talk about, okay, what we're doing here is they've got their alloy is actually a relatively soft stainless steel alloy. That's why he said they're adding extra ductility. That makes it more bendable. But then what they're doing to get the hardness to make it actually bulletproof to at least handgun rounds, not armor-piercing rifle rounds, is that they're cold rolling it. So what they do is they actually squeeze down the metal. It'll come out in what I heard is it comes in a roll stock. So they'll just have a giant roll that looks like you would have, for aluminum foil. That comes in. It's the thickness of the material that you want to use. And then from there, they actually roll it off of that and they squish it down. And there's usually a percentage that they'll, it's either 90% cross-sectional area ratio or 80% or whatever it is, that they're putting it through these rollers. And when they go through that process, they actually transform the structure of that stainless steel from an austenite metal. And we could go into this if we really want to and deep dive it. I've got some things. But the difference between austenite and martensite is actually at the molecular level. You change the way those iron and all those different alloys, you change the arrangement of the crystalline structure of the metal and you make it harder, which then actually makes it more breakable instead of more bendable. So that's why they start out with a soft stainless steel that's more bendable. Then they put it through this cold rolling process to make it harder, but less bendable. And then once they do that, they only can do these nice clean lines. And then this whole air bending process where they put it in a pretty standard bending machine where you would have like a form that it's pushing into. You would lay the stainless steel across it, and then on the other side you would push down into it, and that would actually cause the steel to bend. And then as they're doing this, they're shooting high pressure air on both sides of the material, it sounds like, in order to keep those tools from actually being in physical contact with the metal. And that prevents when he's talking about orange peel, that's where you'd actually see a little bit of unevenness or even potentially cracking right along that edge. and they're preventing all of that by using that air, giving it a little bit of extra float in there so that it can actually stretch right as it comes into that corner. And so all of that is really, really fascinating because this is not something that anyone else is doing, and they have to get every single bend perfect. You know, they have to start with a perfectly sized piece of metal to begin with. They have to bend it perfectly. They have to know exactly how much it's going to deform and expand throughout that process so that it ends up being the exact right size. And then from batch to batch, differences in the material, you know, if you've got one batch of stainless steel that's this quality and another batch of stainless steel that's that quality, well, that can actually introduce problems. You know, you can have one batch that will turn out great and another batch that won't. And so they've got that computer aided control that actually helps them to make sure that the bends come out to the perfect angle every time. That, you know, sometimes you may have to bend it in steps and you may have to hit it 5 times, and then another time you may have to do 6, and another time you may have to do 4. But they've basically got software that handles all of that variation in house so that at the end of the day they come out with those perfect panels time in and time out. And I thought all of that was really fascinating.
Yeah, a feedback loop that they have on that. And just think about it, like Lars was saying, that they're the only ones that use that material. So hopefully the variability won't be too great, so that, you know, bend a couple, see what the results are, and then adjust your bends from that point.
Mm-hmm.
The other big thing is in steel fabrication, the dies wear out. The dies you use to make these bends wears out, and the harder the metal, the thicker the metal, the quicker the dies break. And if you're using air instead, I imagine you're going to have a lot of tooling savings because I don't imagine the pressure is exerted in quite the same way from nozzles as it would be from physical contact.
Yeah, that would make sense to me because, you know, usually there's that friction of the metal on metal is one of the things that's causing those breaks to wear out. And so that should be significantly reduced here.
Okay.
But okay, so why don't we do this? Why don't we start talking about your boron or high strength steel here?
Yeah.
I already asked a couple of questions about whether you're using tailor welded blanks and stuff like that. So you can just, you know, let everybody know what's going on.
Sure. So, I mean, when you look at the Cybertruck, everyone thinks about the skin and how tough it is, and we can talk about that and whatnot. But the other cool part of the exoskeleton is actually this door ring. It's the world's largest door ring, hot stamp door ring. We do it in house with a tailor welded blank, and there's no body side outer, right? There's no skin over this. This is the A surface or the, you know, B+ surface that's on the door inner. And, you know, it's simply coated with a black powder just for aesthetics, basically. So we're looking at, you know, a clean surface here, but it's high strength boron steel, single piece inner and single piece inner and outer. And then we just spot weld it together. And we do that down here at the south end of Giga, Texas, because we had to, much like our castings, we had to make the press.
Yeah. Well, stamping press of this, whose did you buy? Schuler's or
So we have 2 different brands. We have Schuler and AP&T. Yeah.
Yeah. Okay. So if I was going to do it, that's who I'd pick, mainly because I can get the tonnage and the reliability.
Mm-hmm.
So that would be my first choice. So at the end of the day, I noticed there's you've got sealant in here, and then I feel I can feel spot welds, but I don't know what they're spot welded to. So this would be.
Well, the door ring ends here, right?
Okay,
and
so that's where,
here, and this triangle is an extension, just
okay.
like there. So this is actually
so this
the door
would be
ring
the
inner.
shotgun under.
Yeah, this is typical shotgun, right?
Yeah.
And then our casting starts here, right? It's hard to see. Maybe we can go around the other side.
Well, you got one right there, right?
Yeah.
We can use this one.
So this casting here is like right at that A pillar, and it's bolted to the door ring here, and that's where you see the sealant come up through the, you know, through the A pillar.
Yeah.
And that shotgun comes down to about here, you know, because it's one straight line, right? So we don't have, you know, normally the windshield would come here, and then you'd have the hood here.
Yeah.
But this is a pretty big casting. It's pretty.
Is this?
It's not as big as that one.
So is this like 8,000 tons?
No, this is actually a 6,500 ton. The rear,
Are you kidding me?
The rear is 9,000 tons. Yeah.
How? Okay, so How
it's
did
just
you
about
keep it
flow, right?
together?
Like you gotta
Yeah.
like when you think about tonnage, it's about how much metal you're moving within the
Right.
platen size and
Yeah.
how fast you're moving it. But you can restrict that metal flow by like making bad, feeds in bad directions. But when you look at the side, the flow, the biscuit comes in through the middle
Yeah.
right
Yeah.
there,
Yeah.
and then we flow it all out, and we do it like a river because like liquid
Right.
metal wants to move like a river. A lot of times when you see these people copying us, and maybe I'm giving it away stuff, but it's an engineer drew it, right? And they drew triangles and trusses.
Yeah.
Great. But here at Tesla, we have in-house die designers that sit right next to the guys
Go
that
ahead and
design
pause
the
it there. This is beautiful.
Yeah.
What we're
Yeah.
looking at is it is structural, but it's not just structural. It's more about the flow. So some of these lines that don't look organic, I saw a video maybe 5-10 years ago, probably 5, but it might have been 10, where they needed a new dividing wall on an aircraft, the wall that goes between first class and coach. And what they did, it was a custom wall, and they went to a company that does AI kind of design, AI CAD. And it was dumb AI, but it would go through a million iterations. And when they were done, what they had was something that looked organic. It looked like a spider web kind of, but asymmetrical. And what they found is this is the least material you can use to get the most structure where you need it. And when we saw the first castings for the models 3 and Y, you'd look at them and say, this looks like an engineer drew it. You saw these perfect honeycombs, and you didn't see structures like these where it looks like nature made it, because this has to flow in a correct direction. So this is a lot more interesting and clever, I think.
Yeah, if you look at, I think I can remember looking at the 3 and the Y castings, you'll see the crosshatch they're talking about, just regular patterns of X's, but you can see how that just flows, those little curves just flow. And he said right in the middle of that casting is a sprue, is that the right term, where they feed in the molten material. So if you think about it, right on the other side of this wall is where the injection of the material is, the molten aluminum, and it just flows right up onto those little nice smooth curves there. It's incredible.
Mhm.
And that requires less energy. That's where metal is going to move.
And you can see the rivers
Like a
are
river.
taller the rivers are taller at the beginning and get thinner at the end, because if you tried to make it a straight channel, you'd end up with air bubbles at the end rather than it compressing down to fill it correctly.
And he
So
said that
it's-
this was done on the 6500. Did I say that right? 60. Right.
Yes.
And
Yeah,
that
means
means
they're
there's not
just
a Y.
about to get to the point where he says that is the actual gigapress that does the Model Y castings instead of the 9,000 ton press that they need for the rear casting.
Right.
Yeah,
So
notice
when
we have
we
only
had
seen
thought-
rear castings.
Yeah, we had thought that the lack of an operational second 9,000 ton press was a bottleneck, and that they would have to be changing dies back and forth, which is a real hassle and can introduce failures and a new need to dial them back in. But now that we know that this is made on a so much smaller press, and other people are going to be buying 9,000 ton presses to try to do this, hopefully they will learn from this design and take away some lessons that'll allow them to actually get there easier.
Yeah, this is really not easy to reproduce. And, when he talks about why it looks the way that it looks when an engineer draws it, it's because CAD tools, it's much simpler to use straight lines in a CAD tool when you are drawing something by hand as a person. And, 90-degree bends and straight lines and all these things like honeycomb structures, those are easy structures you create a pattern and then you just repeat it and you just put it in there, and you don't know what areas of that structure are actually going to be taking load versus which areas are just extra, and there's no actual force that's flowing through those things until you do something like an FEA analysis where you actually do the simulation and you compute, okay, where is the force actually flowing through here? And then so usually there's an iterative feedback loop. But then once you know those things, your standard CAD tools are not good tools for actually drawing the structure that adapts to the way that that force is going to flow. And so you actually need higher levels of functionality from your CAD tools in order to be able to make those drawings and those shapes to where it does adapt. And so this is not something that, you know, someone like Xiaopeng, who we've seen actually that 16,000 ton gigapress that is being made by LK Machinery right now is going to Xiaopeng. That they are kind of using the dumb. We're just going to make big castings, and just by doing that, we're going to be ahead of the competition. They're not actually going to be making anything that is high up quality as Tesla's making here. They will be heavier castings that are not as structurally sound. There will be a lot of waste, but it will make their assembly process easier and faster. And so, you know, it gets them a long ways towards where they want to go. But it's just nowhere near as elegant as this. And the beauty of what you're looking at here, I mean, it just to kind of gush over it a little bit more, is a work of not only physical art, but the multidisciplinary engineering excellence that goes into doing this, because you have so many different things that are all impacting the way that this looks. You've got your material science, that just having an alloy that can actually flow into these molds at the speeds that they want to, and then to actually harden up within the structure that you want over the time that you have, that is an entire challenge unto itself. Then modeling how all of that aluminum is going to flow, that's a whole challenge unto itself. Then knowing how it's going to react in a crash, that's a whole nother thing all unto itself. And so you have these teams of people that are all experts in their field. They, you know, have doctorates upon doctorates worth of professional experience doing what it is that they do. And you've got a number of these teams that this is, you know, you've probably got hundreds of years worth of engineering expertise that are going into just producing this one single casting, and they all have to work together seamlessly in a way that, you know, most companies, you just don't have those different engineers from all those different disciplines working together that closely on a single unified product.
And then you actually make the casting and test it and find out what needs to be changed because the simulation got something wrong. And then you have to iterate from there. So there's a lot of, yeah.
All the engineers are getting goosebumps just listening to this, because this is what it's all about. This is what we love to do. And then I think later on with you're saying about the FAE, they mentioned how this is, so pay attention to this in the next part of the video, that they pay attention to how structurally this provides support, but also in crash tests it provides support, which is easier. Yeah, but all the Chinese manufacturers are watching this video right now.
Well, and I will add to that, when you were saying that Xiaopeng's ordered a, what'd you say, 16,000 ton press, it's a brute force approach to a solution that's better than not tackling it all at all, but it's still brute forcing something that needs a more elegant touch. But if you don't have that elegant touch, you're at least moving in the right direction.
Exactly.
Castings, and they're going back and forth in simulations so that we can lower the tonnage of the presses we're using by integrating the design of the part into the design of the tool, which is why we don't need necessarily 8,000 ton press for the front. When we started, we thought we would. We said, oh, we're gonna need 8,000 tons. But we worked through the team and we actually can make this front one on the same tool, equipment as we make Model Ys.
That's,
not the rear one.
That's amazing.
The rear one's too big.
Yeah, well,
Helps with cycle time too, right?
Yeah, it does help the cycle time because you get more even cooling across the whole thing.
Well, that's the big thing, cooling and warpage. Everybody asks the same question. I mean, how much does this warp? And I said, well, it happens so quickly, it shouldn't warp at all. But
yeah, I mean, it's really about how long we cool it in the die, and you let the skin cool, and then when you pull it out, we don't have straighteners or anything.
So how many presses are pushing these out now?
We have one for the front, two for the rear, but we, as I said, we have the Model Y ones.
Yeah.
So we have four of those. So we can swap the die out. but we only need two. Like cycle times are down enough to make 5,000. We only need two presses, one for front and one for rear.
So at the end of the day, 5,000. Do you bother with backup tooling then?
Yeah,
Or-
we swap the tools
Yeah,
out.
three sets of dies.
So well, at least two. If we're running one, then we have one backup. Otherwise, we'll have two in and one backup, and we'll rework the one while we're running the other two. And when casting machines go down, they go down hard,
Yeah,
right? And so you got to get the tool out and get a new one in quick.
right. Yeah.
And so we always have a backup die, or it's not even really a backup. It's like we cycle them, right? We're just rotating and maintaining them to always.
So maintaining, I would have thought, well, it depends on, I don't know enough about this aluminum to really, I mean, we did an analysis on it, but I've never worked with anything quite as exotic as this. So what kind of, aluminum is nasty for molds. It's very corrosive and whatnot. And so how much time are you spending then on?
Well, how we do it is we have inserts in the high heat zones.
Yeah.
And we have those inserts, and they might be coated with like a nickeloid coating or something on it to prevent that damage from that local area. And then we have our own in-house die shop. So if that area is getting weak, we'll just replace it with a different insert. And then the platen is really what lasts hundreds of thousands of shots.
Right.
And we may be maintaining the inserts every couple months, every 6 months, but we are making a lot of dies, which is why we made our own die shop.
Yeah, good idea.
Wow. I did not know. I've asked Joe Tegmeyer a bunch of times what goes on in that die shop, and his answer was always, we think they're just making dies. But why? I mean, they've got all these other factories with giga castings, and they don't need die shops there. But there's your answer. They need them. They go through dies that quickly and aggressively, and that also allows them to iterate faster, I imagine.
Yeah. And, one of the things that we have to remember is this is where they do a lot of their engineering as well. And so having a die shop where you also have a bunch of engineers, this is probably one of the places where they're actually developing the casting geometries, and having a tight feedback loop between your die shop and your engineers that are designing the shape that the dies are making is very important. And yeah, I didn't know that they were actually using inserts in these dies, which is fascinating because that allows you, like you said, you can have the rough tooling, the big platen that you can do hundreds of thousands potentially of castings on that, as long as you're regularly maintaining these inserts. And so what you realize when they're doing that is they've got different coatings that they're putting on to try and help improve the lifetime of those die inserts. But then they also have the ability, as they're making new die inserts to put in there, to actually make mild adjustments to that geometry once again. So if they're running into issues with flow, or they're trying to make improvements, just any number of reasons that they might want to make small tweaks to the shape of these dies that are coming out, they actually have the ability to do that with that die shop.
Yeah, isn't it true that most people farm out the dies to other companies, which then adds that lead time to getting them prepared? And
Yes, and if you need one little change, you have to submit a request, hope that they're in a time zone where communication is reasonable, have them make it, have them ship it. But this is right next door.
Yep.
Yeah,
So
I mean, like,
die meant die when we were learning about the die shop, because there was speculation that may have been some kind of something for the batteries. So it's
Well, it's next
die
to the
repair.
cathode plant, so
Mhm.
that's not an unreasonable assumption.
yeah, and I know that the that 16,000 ton LK machine is supposed to be having to do with a casting for the battery packs, or potentially an entire whole body underbody casting for Xiaopeng. And so it may be that they're developing some castings as well for the battery packs on the next gen vehicle, because I expect those battery packs for next gen to be or LFP or LMFP packs, which means there's at least a good chance that they won't be cylindrical cells. They won't be 4680s. They'll be a prismatic pack. And so it may be that you actually have the, external structure that those batteries, those prismatic batteries slot into, is a casting that actually has some structure kind of built into it, since you won't be able to actually distribute as much structural load through those prismatic cells.
I would push back on that. I don't think casting is the right solution for a structural prismatic cell. Casting sheets is fickle, and I just don't think you do it. It'd be fine for the rails of it, but I don't think it would be necessary.
Yeah, I'm thinking the casing that those cells would sit inside of.
Yeah,
The
I still think that
external
would probably be the.
Yeah.
I still think I'm of the opinion it would be an overly complicated solution that would not simplify things as much as it would complicate them. Is my guess. Is just my take.
Yep.
Okay.
Yeah, a lot of people, most people are using co-stamp, I guess,
Yeah.
with their puzzle molds, which I don't quite understand. But anyways, that's where most people are going. And if you're doing it in-house, this is what made.
You like these?
Yeah, I do.
So you know what's cool about these ones on Cybertruck? They're actually tapered because we didn't want to machine this.
Yeah.
So there's no
So they
machining
just-
for the holes or
Yeah,
anything.
so you just shove them in.
So we just twist them in self-tapping and they're tapered. And we have the
Cool.
external for the bigger ones, and then some of them are internal for the smaller ones. But
And these ones here look like they're going to get
These
a
are
screw hole.
self-tapping, yeah,
Yeah,
just self-tapping
self-tapping
screw.
ones. And this is the way to make it work. I didn't know you were doing inserts. So
Yeah, I mean, that's just really about
high
torque
strength.
retention and-
Yeah.
But the other cool thing about the Cybertruck casting is we actually extended it forward. Most of our castings stop here, and we have a crush
Yeah.
can. This is actually the crush can actually is sort of integrated into the bumper, which is aluminum extrusion. And then this is actually the first part of our progressive crash mode, which means it's even bigger.
I love seeing
And
the
that's-
accordion shape
yeah.
there that they have, that you can see that this is a way that they are absorbing that load from the front crash.
So when I saw the castings at Munro and Associates, Corey showed me the original castings and then the newer castings. And what happens is over time they get bigger. They went further out to the back of the vehicle because if we can get more structure in a single shot, we're doing the one shot anyway, get more out of it. And I know a lot of people were looking at the crash testing and saying, boy, that front end just doesn't give it all. And that is true, but look at the F-150, and on a full frontal crash, the tires are what stop everything. Compressing tires is quite difficult inside a wheel well, and you don't want the wheels going back into the cabin. So the amount of force that it was able to absorb before the vehicle came to a dead stop appeared comparable between the vehicles.
Sometimes you want the wheels to pop off, and sometimes you want them to stay in. But I think mostly pop off so they don't intrude into the cabin space. And notice how that gets thicker and thicker as it goes back towards the passenger occupant. I think that's what he's referring to as it's getting beefier.
Yeah.
You know,
He'll talk about that. I think when we get around to look at the rear casting as well, that it's meant to be stronger and stronger the closer you get to the occupants. That way the weaker parts are breaking or crushing or whatever it is progressively in stages, and that you're absorbing more and more energy or dissipating it, I would say. One of the other things that so if your tires end up being part of the crash structure, that's once you introduce those compressible things like rubber into the mix, it becomes much more difficult to simulate accurately. And one of the rumors that I have heard is that the crash test that they did, they had simulated it perfectly. They knew exactly how the real world crash test was going to perform, and it matched one for one. So I wonder if not having it actually incorporate the tires into that event helped in that regard. One of the things that also means, and it just speaks to their that they are a cut above in their ability to perform simulations that match real world performance. And that allows you to do a lot more iterative designs. You don't have to, you can design something in the computer and then you can see exactly how it's going to perform in the real world in simulation. And you don't have to build one and verify that the real world performance is what you think it's going to be, the better that your simulations are. And that's also, then feeds into the exact things that we talked about with the castings as well. Their ability to simulate the flow of that molten metal in the casting helps them actually produce higher quality castings as well. And so, any number of scenarios that they're trying to design for, there's usually simulation that is part of the verification process in any design step. And this is, just a great example of how good they are at doing that.
Yep. Tesla put out that video about the FEA, finite element analysis, compared to the actual crash. I remember seeing that. It's like spot on. Amazing.
It's longer, and we're incorporating more and more parts. I can't give you. Someone asked me an equivalent number, but we never designed this one without it, so I don't know.
At the end of the day, there's a couple of things that people don't quite understand, and one of them is how do these things crash and blah blah blah. And let's just swing over there.
One of the things on the crushability, Sandy, and I'm sure you've seen, is we have different size fins from front to rear.
Right. Yeah.
So we have controlled chaos in the crushing. You can see it even here, like how these build up, and that's so that we know this is going to break first. That section's smaller, the ribs are lower, and then this will get second because each one is progressively stronger.
Right. So, what is this thing based on? What sort of
physics?
Either math or mass, I should say, or speed or what have you.
I mean, the rear crash, of course, we're trying to absorb 305, which is like a 50-mile-per-hour rear crash. But like really, this structure is based on the primary vehicle design. All the suspension loads go through here.
Yeah.
So we're trying to get our torsional stiffness from this. We're also supporting the bed loads. It's 2,500 pounds, and the towing loads, which is 11,000 pounds. And they all go through here. When you put all that math together, right, then you end up with sort of like an elegant load path structure of trying to get back to our nodes at the batteries and the corners and from back here. Then the crash really just becomes a fallout of how do I keep that stiffness where I need it for all those loads to be distributed, and then what can I absorb when I get hit from behind. But crash is actually a simple part of these designs now.
Yeah. Well, for me, I bent the daylights out of the Model 3 when I hit it with a sledgehammer. And granted, that's an 18-pound sledge.
Yeah. That's
not the kind of thing you normally swing around. And I didn't have good access. When I hit the other castings, like the Model 3 casting or Model Y castings, I mean, it just bounced off. And in the what do you call it? In the movie or video or whatever, I swung down and hit the shock tower, and the damn thing came popping right back. And then I found out that my knee didn't like it. So, but there was no damage whatsoever. And I'm thinking that this is less likely to crack or break or do whatever than if I have a bunch of welded sheet metal together.
Yeah, I mean, certainly it's more homogeneous, and it's quite ductile despite its appearance, and so you get a lot of flex with it too.
That's uncommon for a casting to actually have any bendability or ductility or flexibility before it breaks.
Yes. What I've experienced with castings is right after its first deformation is catastrophic failure. As soon as it begins to deform, you'll start to see immediately
micro cracks,
huge fractures. Yeah, the micro cracks, and then it's just done. So,
right, I remember when as a kid, I always thought they were brittle. Castings are brittle, but really, with the addition of different materials, with molybdenum, I think Jordan Giesedy went into that a little bit more. What the different elements are that you put in.
Well, and you can cast plastic and rubber too. But for metal castings, I also did not assume that they would be anything other than brittle.
I think, one of the things that adds to their ability to actually have some ductility is the pressure that they're doing these die castings under, that they're actually getting, because that's one of the differences. If you're going to make a sand casting and you pour something in and you just let gravity control the flow of this material into the mold, then, and it's not under this pressure, that there's a lot more basically microscopic air pockets in the material. And so the same weight of aluminum will actually occupy more space in a sand casting than it would in a die casting like this. And so having that additional pressure that actually compresses the metal together more helps the bonding. There's less opportunities, less basically voids in the casting itself for those cracks to start, which prevents them from propagating, when you are under some sort of load, whether it's, a torsional load or, in stress or in strain, either pulling it apart or pushing it together, twisting loads, those types of things, that it doesn't have the,
Less
even though
porosity?
the shape, the porosity, even though it has a nice shape to it, that the internal structure of it isn't as solid as, because of the porosity that you would get from something like a forging or an extrusion process or other types of metal forming.
And the other thing that's valuable with it being able to flex a little bit is the rest of the car flexes too. And if you've got something that flexes 0%, working with something that flexes quite a bit more, you can have separation.
Absolutely.
So we've got, this is the dual motor setup, front
Yeah.
and rear dual motor. Maybe one thing I'll just say is we kind of have a platform approach to the Cybertruck. We've got 3 different powertrain configurations, but we only have 1 PM rotor stator, 1 IM rotor stator, 1 inverter, and 1 gear set. And so, but with that, we can do a rear-wheel drive, a dual motor, and a tri-motor.
Right.
So it's scalable from like 315 horsepower on the low end to 845 horsepower on the high end.
Well,
So what is a PM rotor stator? What is an IM rotor stator?
Permanent magnet,
PM.
inductive magnet, induction magnet.
Induction
and,
motor.
what was induction motor? Thank you.
And
What was the other question?
the gears, or I forgot what he said.
Yeah, he said they have 1 inverter and 1 gear set as well.
Gear set.
Yeah,
Mhm.
and so
And the inverter is the thing that drives it.
Yeah, that converts the power that's coming in from the batteries into the control that actually operates the electric motor.
Yep, the DC voltage to AC.
And what's interesting is these are very robust parts. If you look at Tesla Plaid channel, I had an opportunity to interview Andrew last year at the Florida TeslaCon, and other high performance stock cars, you take your Hellcats and whatnot, they will have catastrophic mechanical failures if you take them to the track every weekend and run the heck out of them. You will twist drive shafts. You'll blow them up, and they know that. But I think it was his 1700th run on the Raven was his final run before he traded it in on the Plaid, and it was his fastest run by 100th. Fastest ever on his final run. And he's charging all the way up, driving in hot weather, and driving the heck out of it, draining that battery. And no mechanical failures, no gearboxes falling apart. And he was able, and it's just a testament to the quality and strength of the engineering.
the one thing that I've made comments on a lot is the fact that you do a lot of what would be the right word, standardizing on the bits and pieces that and the others can't seem to quite make up their mind. So it takes a long time for them to figure out that, hey, maybe it'd be a good idea if I standardize. So
So yeah, this is the same 4th generation drive inverter that you can get on like a performance Model Y today, is also in the Cybertruck, although it is the 1 kV silicon version, but otherwise it's the same.
And so what he's saying there, the 1 kV silicon, that means that they basically used the same inverter out of the Model Y performance, but they adapted the power electronics to be able to handle the 800 volt architecture, since Cybertruck runs at 800 volts instead of the 400 volt roughly architecture for the Model Y.
I didn't realize that the Y Performance had a different inverter than the long range with acceleration boost.
Yeah, that's interesting. I wonder if that's a
Because-
new introduction.
In terms of specs, they're very, very close. A lot of the difference is the wheels, brakes. But okay, interesting.
It
So
almost
remind
makes
me
you
that-
wonder if they actually designed this new inverter for the Cybertruck and decided to adapt it into the Model Y with the lower voltage, or if it was the other way around.
You see the right by the orange thing, it says 1 kV upside down there. So that's the 1000 volts. Now, did they say silicon?
Mm-hmm.
That's what I
So
heard.
does that refer to silicon carbide? The drivers, or does it use? I always forget which the different drivers are. The switching transistors to do this. You have IGBTs,
BTs. Yep.
and silicon carbide, and so I wonder. It almost sounds like this is not the best. I forgot which was the best. So someone maybe can answer that in the comments.
Yeah, that was my my impression as well.
Footprint, more or less. If you took it apart, you'd be like, this looks very similar to what's in a Model Y, even though it is running at 800 volts in the Cybertruck.
Yeah.
We've got the configurations are for a tri-motor. We've got 2 induction motors in the rear, 1 permanent magnet in the front. For dual motor,
No one understands anything of this.
in dual motor, the PM moves to the rear, and the induction motor's in the front. And then for rear-wheel drive, it's a PM in the rear, and that's kind of what the family looks like. The tri-motor does 0 to 60 in 2.6 seconds, rollout removed, so it's pretty performant.
So first time in a long time, I had to struggle with tires being
That tires were the limit.
the limit. I can actually go a little faster if I can make some stickier tires.
Yeah, but 2.6 seconds rollout removed is for a truck
2.6. Yeah, that's
pretty impressive.
that'll definitely get you to where you need to in a hurry.
And with a single one of these drive units, and this doesn't look very large. This moves the whole truck in under 6.5 seconds in the rear-wheel drive configuration, and can still tow 7,500 pounds. So, significant.
Oh, I thought it
capability.
was 11.
Dual and tri is 11.
Oh, I see.
Yeah,
dual
Yeah,
and
rear-wheel
tri, I
drive
see.
7,500.
I
Yeah.
see.
But other than that, you'll see a lot of familiar parts, like even down to the oil chiller, the oil pump, a filter. Even the
This is the same one that's on my wife's tractor.
But yeah, when you take it apart, you'll see familiar pieces. The actual size of the rotor stator is actually smaller than it is in a Model 3.
No kidding.
Because we're taking advantage of the gear ratio, the fact that the top speed is lower. So this is a 15-to-1 gear ratio. So
What is the
got-
top speed?
130.
Yeah, 112 for the lower.
And you've got, big.
It's fast enough to go through a swamp. Yeah, good.
The one way to think about it is in terms of rare earths, because I think that's one thing that you've been
Yeah.
tracking. We still do have rare earths in the Cybertruck, but the amount of rare earths in the Cybertruck is no more than that of a Model 3, but it moves the Cybertruck.
One of the things that I just wanted to mention as an aside is that I know that Sandy obviously was tickled pink to get to talk to this executive team, but it seems to me like they are, at least, Drew and Lars especially, are as excited to talk to Sandy about all the work that they've done as he is to talk to them.
I would agree. They've been working on this so hard for so long, and they were not allowed to tell anyone except each other. And now there's cameras and permission. This is very exciting.
Yeah, and you see,
Well, and they
Sandy doesn't
obviously-
pick up on some of the things too when they try and sneak little tidbits in.
Yeah.
Yeah. and you can tell that they've watched his teardown stuff. Obviously, they know exactly what he has and has not looked at. And so there's a feedback loop that's obvious that, they've been taking his design suggestions to heart. And, he's talked about that plenty of times, that they move at the speed of thought and he suggests things and then poof, all of a sudden there it is in the vehicle.
Magic.
Cool.
So yeah,
I'm
they look-
assuming
they
he's
look pretty
working with
similar.
them. Right. He said before in the previous interview, he's under NDA. So I assume that maybe it's right, maybe it's wrong, that he actually worked with Tesla on some design or just couldn't reveal anything. I don't know.
I don't think that he worked with them on the design. I think he, like the other reviewers, got early access to see it. And that was the NDA, the one that expired at midnight on Friday, the 1st of December. But because he doesn't know a lot of these answers, and he's still committed to tearing the truck apart. And if he's going to tear it, if he was working with them, I assume one of the clauses would be, you don't do a teardown for others. Would be my guess.
Good.
To what you've seen before, but they.
Well, actually, we've never taken apart a hairpin motor.
Oh, yeah.
None of your hairpin motors.
These are hairpin motors.
Yeah, so it'll be perfect if I could get a hold of one.
I mean, yeah.
Well, unfortunately, I couldn't find a job.
Even that statement right there, that he hasn't gotten a hold of one yet to tear down. I mean, I know there has been some discussion back and forth about whether or not Sandy is under NDA for design purposes, and some people think that he has. I think I agree with Brian on this one. I don't know that he has, and I'm really hoping to see the tear down. And I don't think that he would have been trying so hard to get an early reservation holder to give up a truck, or talking about trying to get a hold of one of these hairpin motors if he was prevented from being able to do that.
For electrification in the US. So I spent from 2014 to 2019 in China. And one of my rules was every engineer 1 gram every day.
Nice.
And guess what? It in the beginning, look what I did. And then at the end, oh God, it's not possible. Yeah. So they were actually going in and drilling out the center of the heads,
Sure.
bolts and stuff like that. It was a good, hey, you know what? If you take a bunch of grams and you glue them together, you get a kilogram. Yeah.
Yeah, no, but I mean, through optimization, it literally was a game of kilograms that we pulled out when you consider the tri-motor.
Yeah.
I mean, that's one of the coolest things about Cybertruck. The mass of the thing is just like, it's about 2950, 2980 kilos. So, what's that, 6,700 pounds, 6,800 pounds? It's like normal big truck stuff, even though we've got, massive, I don't want to, bullet resistant doors and, 3 motors in it and giant battery.
And
like,
that's usually the big killer with stainless steel. They say it just weighs too much. There's no way we could survive with that. But if you can reduce a lot of the internal structure, doublers and triplers and whatever,
for all
then
of it.
yeah.
Good. We can do the controller first. Yeah.
I like that little tidbit there about, or all of it. Like, we're gonna, try and get as much of that structure to the outside of the vehicle to the stainless steel as possible.
Can you
And
tell
that's
us
what
what
they-
doubler and triplers are?
What?
What doublers and triplers are? Are they just structural members inside the vehicle?
I don't know an answer to that one. Maybe someone in the chat can tell us.
So if I remember correctly, hearing Munro talk about that usually when they do like a body side outer stamping, it's usually several layers. And so they'll actually have some high strength steel that will be inside it. And then there might be an area for crash worthiness where they need extra strength. And so they'll put an extra piece of even more of that high strength or ultra high strength steel in that area and add it in. It might be sandwiched in between, a high strength steel piece and then a lower strength steel piece. And so I think, if I remember correctly, that those doublers and triplers are those basically just extra layers of sheet metal when they're creating those stampings in order to get extra strength and rigidity or crash worthiness in specific areas.
And that's what my comments are lighting up, saying that yes, it's just adding additional layers. I know in the B pillar, they will often do two types of steel, where it'll be like a high strength steel and a mild steel, because they need the structure, but they also need the strength, and they don't want to do the expensive kind for both, or use something that's so thick you can't work with it.
Mm-hmm.
Yeah.
This is the left controller in the car. So it's 48 volts. This is one of the Etherloop connections.
Have a peek at that. That does not look like an ether cable. It
It's
looks
a
a bit
standard
different.
twisted pair shielded cable. Yeah. And then this is another one going to the rear controller. And then this right here is the switch tank converter. So that does 48 to 16 volts, and it's bidirectional. So when I was talking about jump post, on the jump post, the current flows back from a 12-volt battery to jump to 48.
So do I understand correctly that they're saying you can jump the Cybertruck with a 12-volt car, but also you could jump a 12-volt car with the Cybertruck? It is bidirectional. It flows both ways.
Certainly sounds like it, though I would advise against it.
Or it's just that, if your low voltage battery, which it is on, the low voltage battery is on the cross car beam member in the front. If that dies, you lose all electronics. So you have to feed either 48 volts to it or 12 volts to it. And I think it's mostly just to jumpstart the Cybertruck in case that battery goes low. The low voltage battery goes bad.
And then one thing that's different is this is mounted on the firewall, and so it spans the wet side and the dry side, which is new. We haven't done that on the 3 and Y. So one of the things that can happen is circuits on the wet side can come through and just transit the board and then go back out, and that allows us to remove a whole bunch of grommets that used to go through the firewall. What else is cool? Because the current's much lower, the eFuse circuits are much smaller. I can't even point to them. They're all like up in here somewhere.
Yeah, really tiny.
Yep. And then this is the microcontroller that runs the Etherloop.
Really? All by itself? That's amazing. What's this chip doing here?
That's another microcontroller that does a lot of PWMs for like controlling window motors and things like that. Yeah.
It looks really compact.
It is.
Dense.
Yeah. Well, the problem that we're facing now is that it's dominated by the connectors. So if we could get rid of all these connectors or densify them, that would be a lot nicer. And we've been using this style of connector for quite a while. So we're just pinch stitching on the module, and then the connector itself is formed into the cover. So this, when you see it in the car, the cover on top of this forms the body that the connector actually connects to.
Yeah.
So we don't really buy connectors, like for example, like this one where the shield is already in there. So that's pretty fun. And then because of 48 volts reducing the current, that reduces the loss. So when you see it in the car, the heatsink is significantly smaller. And really one of the reasons we have the heatsink is the audio amplifiers are here. So we used to have a separate box in the car for the audio amplifiers, and now we've been able to integrate them onto the car. Yep. These are still these are 24 volts. But in the future we'll push that to 48 as well.
If you like, one of the things that we had when I was trying to push this in the 80s, 48 volt, I thought I couldn't understand why we're still using 12 volt.
Right.
And one of the reasons that I wanted to do it was because I could get rid of almost every heatsink in any of the because it's old fashioned, right? Mm-hmm. And by going to 48, I could get rid of those heat sinks, and they're cheap, or everything was nobody cared about mass. In those days, it was road hugging weight.
Really?
That was
we have enough of that.
Yeah.
But I squared R, you reduce the voltage by you increase the voltage by 4x, reduce the current by 4x. It's 1/16 the heat.
Yeah. 16. Yeah.
No, we like it.
That's a good idea. I can hardly wait to see who comes in second. It always seems to me that you guys pave the way, and then everybody else becomes an expert. And usually the guy that comes in second, Wall Street throws rocks at them as well, saying that, you know, they've done another dumb Tesla thing. And that's what happened with what's his name, Jim Farley, when he went to your connector, the North American. Yeah. And now everybody's done.
He looks a little
Everybody
smarter
except
now.
Volkswagen. Volkswagen is not doing
You
it.
know,
Yeah, well,
that domino will fall eventually.
yeah. Yeah. So here we are.
Yeah, this is.
Can
you've
Pause for a second, Hans. So what he was saying before about that body controller is that's very critical. I remember our designers, the mechanical designers that made the housing for our device, the connectors are a big part of that. So they integrated the connectors to the housing. So the housing, you know, when it's formed or whatever, you know, however they
Probably
do that.
plastic molded, yeah, like an injection
It's
molded
probably
plastic piece.
with yeah. So they incorporate it into the housing one piece, so you don't have to buy the connector from a connector manufacturer. And also the thing about the grommets, so you seal it on the one side, that's the wet side, and you don't have to seal it on the firewall side, which is the dry side.
Yeah, and it
It's
looked
great.
like they had those two holes that were drilled just all the way through. And so I'm assuming that there will be a cable that just passes directly through. You know, it's not like they're bringing it in, they're plugging it in on the one side, and then they have connections, and then it comes out on the other side. It seemed like there's actually just going to be a cable that doesn't even interface with the board that passes straight through there. And those grommets will be, once again, built into the housing on the front and the back side as that cable goes through there. I thought that was fascinating as well.
Oh, and the other word, densify those connectors too, because that's always an issue. You know, you want to make them smaller because they take up all the board real estate.
A question that I had, because some of the comments here, by switching this to a higher voltage, we don't need as many heat sinks. Is that true?
Yeah, so that's what he said there at the end when they were talking about I squared R. So P is equal to I squared R, I believe so P being power, I being current, R being resistance. And so if you step up your voltage by 4 times, then you actually, and then you square that, or squared is 16, you reduce the heat. So heat is going to be proportional to your resistance. So that's where he got that number, that you're reducing the amount of heat that you're generating by 16 times. And so you can imagine if you're reducing the heat load by 16 times, that you obviously don't need nearly as much infrastructure to dissipate that heat. That's why you don't have as much heat sinks.
It all depends on the circuitry too, because, you know, for instance, when you're converting a 48 volt down to, you know, 1.3 volts or something like that to drive the processor, that's a bigger difference than 12 volts to 1.2. So it depends on what you're trying to do. If you're trying to convert voltage down, then it's actually less efficient, probably. I don't know, maybe I'm not the expert in this, but, you know, there may be some trade-offs there. I think they're just referring to mostly just I squared R losses in the wiring itself, wiring harness.
Okay.
I don't know.
Well, and even the traces inside the chip, I would imagine as well, that if those traces are operating at 48 volts instead of 12 volts, then, you know, it applies
finer pitch on the wires.
Chip. Yeah.
On the PC board itself. Yeah.
Yeah.
And probably the layers in the PC board too.
Taken apart a couple power conversion systems, I know.
Yeah.
So this is,
none of them look like that.
this is the next generation power conversion system. We call it the PCS2 at Tesla, where we've gone to everything being, you know, surface mount reflow process and no whole, you know, through hole based parts. We've got
These aren't through hole?
no.
Wow.
And with these,
So what does that, do y'all have thoughts on going from through hole mounts to surface mount? What does that get us?
Yeah,
I don't.
I think I'm not sure what he was pointing to. Hopefully he was pointing to those transformers or that big gray piece, he said, that's not through hole, because usually those things are through hole. When you put a hole through a PC board, you got to remember that there's well, first of all, the way that you have to solder is different, because you have to instead of reflow like the surface mount, you have to put it over some kind of laminar solder bath to solder the bottom of it. So it's a different process, right? So if you remove that process, it's one less step. And also it adds other strains and stresses to the PC board. Did I answer? I forgot if I answered that all.
Yeah, no, that makes it. So there, yeah, less processes, and then probably, is it less heating for the board overall? So it's not bending and or having localized heating. It's more uniform heating across the whole thing, so that it doesn't do any,
One less heating, because
warping.
you don't have to reflow it then on the bottom. But I bet there's components on the bottom of this board too, because the pick and place machines for each one of those components will put it on the bottom and the top, and then I'm not sure if you have to put it through a reflow oven on both sides. Then I've lost that information.
And so
ago.
reflow, yeah, basically they just have the solder that they need is already attached to the component, and then when they put it through an oven, it automatically basically solders itself to the board.
Yeah, you take that PC board, the blue thing that you see in the back, you put a silk screen down, and you put a paste on it, like you do silk screening in shirts. You just put a little bit of paste on each one of the soldering pads, and then you take the pick and place machine, and with a little bit of glue on it maybe, or even just a solder paste. So you put in each one of those positions, and then you take it through an oven, and it heats it all up, and the solder just melts and solders it all there.
Yeah, and then probably run it
neat.
through a test and make sure that everything has solid electrical connection after that.
Yeah, you can do a couple ways. You can do X-ray checks on it. That's pretty expensive. Or you can just do test points all through the board, make sure all electrical conductivity is met. Or you can just have the whole board diagnose itself when it powers up for the first time. There's probably some kind of test on the end after it's been reflowed.
These are all planar magnetics. So none of these, you could almost, they were look like they were made by hand, the large inductors and chokes that you saw before. All planar magnetics, leveraging the PCB. You can see the traces in the PCB that are part of the circuit there. We've accomplished a doubling of volumetric efficiency from a power density perspective, and a 50% increase in gravimetric power density. One of these PCS2s in the truck does 11.5 kilowatts continuous bidirectional on the charge port. So you can power the house.
Okay, so that's the other question I had. Can I power my house?
You can power your house.
So I know the conversation that we were just having about that whole reflow process, it sounds nerdy, I'm sure, to a lot of people, but it's important because that is one of the, if you're transferring 11 kilowatt hours of power either into the vehicle or from the vehicle to the house, that's a large power load. And so having high quality electrical connections that are very consistent and a much more automated process of making all of those electrical connections between all of those components, it lowers the chances for there to be failures in any individual component, which could then cause, these are very safety critical systems. That thing is the difference between your truck catching on fire or your house catching on fire and not. And so, we don't want to see burning Teslas. And this is a big piece in actually achieving the safety, along with being able to have high power density being, transferred into the vehicle, which we need in a truck or a semi, these types of applications.
11.5 kilowatts continuous, 110 amps of inrush current capability for, you've got your air conditioning units or whatever in the house. We've got 4 120 volt outlets and one 240 volt outlet. The 240 volt outlet is in the bed, so you can just charge another EV right off the back, or do whatever you want to do with 240 volts. And we've got 3 kilowatts of 48 volt power, all in this object. You've got your 4 power stages there on the high voltage side, the 2 power stages on the 48-volt side.
So what does it look like if you get the extended range version? Because I know that there's something coming out with extended range, right?
What is what is this? What does
The
this
extra
look like?
battery pack.
Yeah.
Does that?
We can show you. I mean, it basically sits kind of in the bed.
Yeah,
It
it looks
raises
like
the
a
bed a
toolbox
few
in the
inches.
bed. That's what it looks like.
Oh,
And you can get over 460 miles of range with that extender.
460 miles. And what would that be? if I
Long-term
was
target is
turn-
500.
That's right.
What about towing and whatnot? If I have an 11,000 pound thing that I'm dragging around, what does that give me? In
Yeah, I
the
mean,
way
it
of-
depends
Yeah.
on the aero
It's
efficiency.
less the
of
weight
thing.
and more the arrow.
Yeah, it's like if you pull a horse trailer, it's pretty bad, and they take away 50% of your range. But if you pull a Ski-Doo or something a little more aerodynamic, you might be like 20 or 30%. I mean, the cool thing about Cybertruck, Franz did a good job on, was that tail really gets with the tonneau and everything.
Yeah.
It gets the air flowing fast, and
Yeah.
it makes a taper, so we get pretty good straight laminar flow off the back.
Right. Yeah.
And as long as that's not getting disrupted by whatever you're towing, it's really just the mass,
And also,
process.
we're scaling up regenerative braking power based on the mass that we sense inside the vehicle.
That's
so we're
right.
doing our best to recapture as much of that energy as possible, so we don't at least waste it on friction brakes.
But yeah, with the range extender up over 460 miles, and obviously if you're somebody that tows a lot, like I don't know, San Francisco to Tahoe, the range
Yeah.
extender might make sense. But
Well, the average person drives 40 miles.
that's it.
I mean, it's
That's
like
why I decided to make it an optional add-on.
And I mean,
Yeah,
most people,
exactly.
340 miles, 320 miles, what we're gonna give in the dual and the tri, like that's totally fine, like for anybody. And then we want to make more electric vehicles, right? So like rather than putting more cells in
Yeah.
that no one's ever gonna use,
Yeah.
if you want it, you can buy it.
Well, I don't see the need for, at least for me anyways. If I'm going to go into the woods with something like this, I'll charge up before I take off. And if I decide to lose my mind and, travel some other place that maybe I shouldn't have,
Use the charging network.
exactly.
Yeah.
And that's it.
One other unique thing that we're doing in the Cybertruck is we're actually able to natively charge at both 400 volts and 800 volts. So we actually take the battery and split it in half.
Really?
When we're at a Tesla supercharger station that's a 400 volt station. So rather than having to go through a boost converter that could be slower and efficient, we just directly connect the supercharger to the battery terminals, whether it's at 800 volts or 400 volts. And that's all happening with this. It's a dual pole, dual throw reconfigure of the bus. You can kind of see here the bus is in parallel. There it's in series. And that's what's happening in our device cluster area of the battery pack, where we've got the Pyro devices, we've got the main switches, and then we have this DPDT, we call it, that configures the bus between a 400 volt bus and the 800 volt bus. Which does mean that things like the power conversion system, the HVAC compressor, and everything else need to be able to work at both voltages, but actually that isn't very complicated when you think about what they are. They're all variable speed drives, variable frequency drives that have power converters in them already, and they're already designed for the higher voltage, so they can run at the lower voltage too.
Cool. Way cool. Okay, now we're into where I actually...
Jess.
Yeah, let's talk about the towing real quick. So in my comments, a lot of people are saying, well, if it's pointy, if it's brick shaped, the thing with a horse trailer is a very good example, because a horse trailer is not pointy or a brick. It's full of holes and vortices, and nothing will slow you down worse than a mesh of vortices of swirling air dragging from all sides in all directions, unless I'm missing something.
Yeah, no, that's totally true. And then the other thing about a horse trailer is just it's a large cross-sectional area. And so your aerodynamic drag is a function of two different variables. One of them is, what is the coefficient of drag itself? But then the other one is how big of an object are you trying to punch a hole? So, the same shape, if you did a semi and you made it the height of a car, it's going to have a lot less aerodynamic drag, even though the shape is not very aerodynamic, just because it's smaller. And yeah, horse trailers are typically tall, they're wide, and so they have a lot of cross-sectional area. And then, like you said, all those vortices.
I would say the best thing to tow behind a Cybertruck would be a pop-up trailer that is the same height as the back of the tailgate.
Yeah. Yep.
Oh, and
Okay.
and now on the electronic side, he was talking about they showed a little picture, that schematic under the
Mhm.
dual pole, dual throw switch. I zoomed in and took a picture of that to see if I could see anything later and play around with it, maybe.
Yeah, it's
The
interesting.
That's pretty unique, isn't it?
I don't know. It seems like a very simple and elegant solution in a very tight package. So it seems like a great idea.
Yeah, very
Well,
simple.
yeah, and it's very important for, being able to use any supercharger. So you can use all the V1, V2, V3 superchargers at their normal rated output. And then you can also
Yeah.
use the V4 one that's going to operate at 800 volts and get even faster charging. You're obviously going to get a lot faster charging out of that V4. I think we've even heard that it'll go up to 350 kilowatt charging on the V4 with that 800 volt architecture. So that's really cool. And it also, it makes me wonder that additional battery pack that they can put in the bed for the range extender, is that going to be a 400 volt pack or is it going to be an 800 volt pack? I mean, I can see kind of arguments either way.
Right. We don't
And it
know
looked
if
like
that's going to
Sandy
be.
was. Yeah, I was just gonna say Sandy was trying to get an answer on that, and we didn't get one. Go ahead, Ken.
Right, because there's been talk about whether or not this extra battery pack that you put in there is a 400 volt system or 800. Is it directly connected to the battery pack? Some people have seen some, what do you call it, coolant lines coming off the top of the cover of the current battery. So maybe it shares some of the coolant from the current coolant loop, but maybe it's just a range extender itself where it has maybe a DC-DC converter, because you can't, when you have a battery that's a whole thing, you can't really, I don't want to say it, it's at one particular voltage and it degrades with time, right? Now you introduce this range extender and it could be at a different voltage than those degraded cells. They might be a little older. So maybe there's a DC-DC converter which bumps up to the 800 volts, and we don't know how it's going to supercharge. Maybe it won't supercharge. We don't know any details on it, but these are just ideas that are being thrown out. And Kyle Connor has been talking about a few of them. So if you ever follow
at the very
him on
least,
Out of Spec.
Oh, and his stuff has been excellent as well. I've really enjoyed the videos, and especially the podcast, the Out of Spec podcast this week have been good. But, at the very least, the power that you're having to transmit between that additional battery, like they're going to have high quality, high power connections. And is it going to the battery, like you said, or is it going into that power module there that Drew was just showing? Because it sounded like that was the question that Drew was hoping that Sandy was asking is, are we handling that that external battery here and the power flow between them here, or is that happening somewhere else? I really wish that we had gotten that, because that would have been an interesting answer. But then, like you mentioned as well, the cooling is another thing that, it could be that they're doing the cooling on that is just air cooling essentially. That pack is basically not meant to really handle high power loads, and they're not going to do heating as much. So that whole thing is also going to be really interesting, and I can't wait to see what Sandy's tear down. Hopefully he gets an external pack and I get to tear that down and we get to find out all those answers.
Right, because if it's a DC to DC converter, it could actually act as like a little range extender like a motor that you have on range extenders. Sometimes it would act as that, and it could just charge up to, who knows, when it needs it, could slowly charge. Yeah, again, don't know details, just speculation.
Two parts.
Even more interested in, and that's steer by wire.
Steer by wire. You asked
And
for it on Model
I
S.
did.
We did it on Cybertruck.
I thought you were going to bring it out
He's
on
been
the
seeing
Model
ZF
S.
out
Scare
there.
the
48
crap out of
volts.
everybody.
Sometimes things take a little bit longer to bake.
Yeah.
Yeah. I mean, between David and me, this is a labor of love, I would say. There's a lot of functional safety that went into this, but it's a typical steering rack, right? We went to a pinion drive on either side because you don't need like the feel that you might get when you're driving, because the feedback actuator at the wheel handles that. But these are two smaller 48 volt motors, in-house designed, and we work with our vendors to make them, but they're roughly 50-60% of the power capacity we need. And so most, as you know, like most steering capacity comes at like parking lot loads when your brakes
Right,
on
yeah.
and you have to scrub the tire. So we didn't want to oversize these to do that. So if there is a faulted state and you lose one motor or one controller or one side or one power bus or whatever, you can still drive quite easily on the other motor all through the highway, pull over safely, whatever you want
So
to do.
that gives you a double redundancy.
Yeah, it's double
And
redundancy.
actually, like while you're driving normally, like 50% of the torque is coming from each one of those
Yeah.
two
Yeah.
motors.
Make sure
And
they're
the same
both
thing on the
Yeah,
on the
right. Which is a good idea because in aircraft we've been doing this forever,
right?
and
You want to be redundant, but you also want to be differentiated. So you can see on this side, we don't have an angle sensor, but on this side we do. This side we have a position sensor, just so that we have different signals coming in from different motors. to make
diversity of different sensing
diversity
modalities
and redundancy.
and computation as well.
Here's a cool trick though. This is a rear steer one.
okay, so I know absolute. Well, we've done this on buses and things like that,
Yeah.
but we've never seen anything like this on.
Well, it's a big vehicle. We wanted it to drive like a sports car, and so make rear steer's the ticket to make a big thing
Yeah.
feel small. We get about 10 degrees, 8, 9, 10 degrees of rear steer with this per side, and that's mostly at low speed.
That was one of the things I was interested at is do they use the redundant actuators for rear steering? And based on what we're looking at there, it looks like there's only the one actuator for the rear steering. And so since it's not safety critical, they didn't worry about having two of those there in that location. So you've only got, I guess it's so you actually saw this, Ken. This is a good question to ask of you. On the front cradle, do they have, is it just this what we see here? Is this the whole setup where you end up having 3 motors, or were there actually 2, was it redundant double systems to where you had 4 actuators on the front steering assembly?
I believe there's only 2 motors on here. Probably the redundancy. Well, the redundancy is that there's 2 motors, right?
Mm-hmm.
One can. They're only using half the torque for each one at normal times, and I bet inside there's probably maybe 2 power feeds, 2 grounds for each one of the motors. Just again redundancy. What was
But
the other thing?
is there linkage connecting the left and right front wheels?
Well,
Yes.
that is a rack, right? So the rack
Okay.
is one continuous shaft, which is
Okay.
driven on either side,
Okay.
right? So there's a
Okay.
what do they call it?
Gotcha.
The pinion gear, right? Isn't that the one
Mhm.
that you don't get any backlash on? Again, you're going into mechanical stuff for me, so. But yeah,
Which
so yeah,
You can talk. I'm just trying to scrub to where we can. Here we go.
yeah,
You can see it.
yeah.
So
So
that
I
right
gotcha.
there is
Mhm.
this is connected from both sides. This is one solid piece, and then this is where you've got your universal joint, so that you can operate the steering knuckle at any angle of steering, and then as the wheels are going up and down too.
point to where the pinion
It-
gears are
yeah.
on there. You can see the 2. He's gonna
Yeah,
show you.
there's
one.
here's the gear that's coming off the motor, and then inside of this housing, there's it's basically a long straight gear with teeth on it that will
And
go back.
and these
forth.
asymmetrical redundancies, this is one reason this truck took so long to design, is it's got a lot of new great engineering in it that we didn't see before. That it would have been easy to just shoot something out and hope for the best and fix it later, but this looks like the sort of thing that isn't designed with that philosophy, but to actually work right the first time.
Right, and he even said about the sensors. The sensors are the sensors are different. So a positional one on one side, and I forgot what he said on the other one. So they're not in the same. They're not co-located in the same spot. So you have some.
Yeah, and that's to prevent in case there was a disconnection, if a wire got severed or something, that you wouldn't lose all of the data for the whole system all in one place, and then have other wires that wouldn't matter at all, that you can kind of have things spread out, and parts of the system will go down at different times. And then you can even have have multiples of them in different places. So if you lose one, you've got an extra.
And the back, since that only has one motor, I figure that that's going to fail in a position at less than 10 degrees, or maybe it might center. I don't know. Maybe someone knows that answer too, how these things do fail if they recenter themselves. That's probably why there's no redundancy on the back, because it's not as critical, just the front is critical. And then you get a warning and then go to service. But there was something else. What was the other thing about that? Yeah, so that rack I saw ZF or ZF. So they probably make the rack. And then they mentioned that they worked with their vendors. So these were in-house Tesla motors, right? Kind of like the Optimus robot. They're making all their own motors.
Right. Because they know what they needed to do and they know what works better than. And getting the supplier to get the right thing to the right specs, like we said earlier, can be months, years of back and forth.
Buses and things like that, but we've never seen anything like this on.
Well, it's a big vehicle. We wanted it to drive like a sports car, and so make rear steers the ticket to make a big thing feel small. We get about 10 degrees, 8, 9, 10 degrees of rear steer with this per side, and that's mostly at low speed. So we get about 9, 10 degrees of rear steer with this thing, and the cool thing is this motor is the same as this motor. So the controller and everything, we have 3 of them in the car, and they're all the same.
Oh man!
Back to the reuse thing.
Yeah, I learned that. I learned that one
day,
from Drew.
I do not understand why it is that there's. I can tell you why. Well, I do the front steering, and he comes up with something. Well, I do the rear steering, and she comes up with something different. And then we
Same team.
Yeah, same team.
Person,
Good idea. Same person. You can't go wrong with that. Yeah.
You really notice
So-
the nimble drive with the rear
Oh
steer.
yeah, it makes it feel tiny.
Yeah, it completely
So-
changes the feel. of the
Does
car.
it spin on its own axis or something?
No,
like that?
it's not that. I mean, but when you're turning, it feels
Yeah.
like your yaw center's behind you, which is kind of cool because you sit a little bit more forward. So, it's super easy to move around, even though it's a big truck.
So lock to lock, what have we got?
Less than 1. It's 340 degrees.
That's a good idea. What about like?
Never have to take your hands off the wheel, so
well,
it's variable at speed, right?
Yeah.
So we get a little bit slower ratio on the highway, so it's not as twitchy. A little bit faster when you're in the parking lot, right?
Is there anything that y'all want to say here? I know a lot of people have covered this aspect of the variable steering ratio kind of ad nauseum.
It's going to
Not
be
really.
incredible.
I mean, yeah, everybody appreciates the nimbleness. Some of the reviewers found it a little harder to adjust to than others. But the thing with this getting rid of the blinker stocks, my complaint is roundabouts. My city has some really outrageous and ridiculous ones, and I can't find a stockless blinker when I'm exiting a roundabout if I don't know where my hands are on the wheel. And with lock to lock, it's right there. It's always right there. So that would allow finally to get rid of the stocks. Please don't get rid of them before that.
Right. It makes it that design decision much more applicable to the Cybertruck rather than the yoke on the S and X, even though people don't have issues with it. And it must be nimble, because I remember driving a Prelude, Honda Prelude, when they had rear wheel steer, and that was a really fun feeling in it. So that's what they're talking about. And you remember, Sandy didn't have the truck at this particular point in time. He had it later. That's why he said, "Oh, what? It's less than 1 is the full." So he's just beginning to realize this.
Cool. Oh, excellent. And when
The last part we got to show, I guess, this is we have about a little more than 12 inches of suspension travel. We want to be super great off-road. And so we have air suspension on all 4 corners, and then we have adaptive damping, to make it ride well when it's low or off-road or high. And we have independent control of both compression and rebound valves, so that we can switch with that ether loop communication system at 10 milliseconds, which is basically the frequency response of the hydraulics, right? It's super good, and you'll notice it when you drive it. It's really competent on the highway, but when you go off road, it's also super comfortable. It's not harsh and whatnot. And we can keep the body roll down, the pitch down. I mean, it really does drive like a Tesla. And that's something that we really, really wanted it to be. Not this unwieldy, big thing, but like feel small, nimble, like a sports car, like every Tesla's made, have 0 to 60s of 2.6 seconds and all that torque. Then we had to really add this to unlock it.
But it's not, it's not pitching like crazy in response to the torque. It's very settled and comfortable drive.
Well, this people are asking me about, is this going to basically eliminate the Rivian or the F-150 or whatever? And I don't think that's going to be the case. What it is going to undo is Jeep. I mean, I never thought I'd ever, because I've been driving Wrangler since forever. But after they gave me I bought the new one. What a disaster! I mean it sincerely. I could not believe that they put that thing out. All right, so let me just ask a couple of quick questions.
Of course.
So it's steel, and you showing the two.
Just on the suspension thing, I wanted to say that the Haggerty, when they drove the Cybertruck around the go-kart track, is a great testament just to how well Tesla has executed that suspension, because it has to handle all of that roll. Like for that car, not only to have the steering radius with the 4-wheel steering to be able to make those turns, that's huge in and of itself. But then to be able to navigate those turns at speed, that's where a suspension comes in. So to be able to do that in the same vehicle that can then go and do Baja, there's no other vehicle that can do those two things. Like, your Raptor might be better at a Baja event. Maybe. We'll see how that goes. But it certainly can't come off of the Baja and then go onto a go-kart track and make all those turns. And so, just an incredible feat of engineering for them to make this truck that performant and that versatile at the same time.
The Raptor also costs more than the Cyber Beast. That's not great. And in the Haggerty video, he was saying, if I was in any other truck, my hands would be blurry from all the turning.
Mm-hmm.
Yeah.
Something before you continue on, Hans. Notice how Sandy tapped the battery pack at this point in time. It said steel, right? And then watch what is it Drew that's right next to him? Watch, he taps the bottom. He's trying to tell Sandy something. Try and think.
It's aluminum.
It's aluminum on the bottom.
It's aluminum because for fire safety, when there's a fire in there, it drops out because the aluminum has a lower melting point.
Right.
2 seats. Okay, so just kind of curious. I'm assuming there's more to this than
there's carpets and center consoles and other things that we're missing. Wire harnesses and
that all get married.
And is this? I'm assuming it's the 4680 batteries.
4680.
Are these the new dry cells?
This is the 9% higher energy cell that we're making in Texas now.
But it's dry. It's not like the because that's what I saw when I came here with the investors. Where's the shrimp? That's the only thing I can remember. I heard it twice.
Really?
So yeah, they had no idea what they were looking at, and I was about peeing my pants when I was watching the anodes being
electrode produced here.
Yeah. Cool. Okay, so let's look at the trunk, and then we can go out on the floor, or frunk, whatever.
I know you did the teardown of the Model Y structural battery. Like, we've certainly evolved it. We would call the Model Y structural battery maybe like a grade C. This is more of a grade B.
You can already see some of the.
I just wanted to stop there for a second. So it is good to hear Drew say that, we're not yet, they don't have an A in the A architecture of the structural battery pack yet. So I don't know if it's the quality of the battery cells themselves that are coming off the 4680 line. I think there's obviously room to improve those. Or if it's more to do with just the overall implementation of the structural battery pack. Do y'all have any thoughts on that?
No, I think it's all of it. I think it's every last part of it. They want to, when a factory hits 100% capacity, they've got another 2% and then another 2% and then another 2%. And I think that's what we're seeing with the battery packs is we're very, very good. We are the best in class, but we have not stopped practicing and getting better.
Right. So maybe gravimetric density, energy density, and there's some improvements. I defer to Gordon GCD for all that. He put out a tweet on it today.
Yeah.
The ground clearance, so this is the suspension and basically off-road mode, and it's a flat floor. There's no diff hanging down in between, so you get true ground clearance.
For off-roading, we've also leveraged all the work that we did on our own in-house stability control, like for track mode, to apply like more dynamic behaviors for off-roading, both rock crawling and for like Baja.
Well, I can put 3 shotguns in here, or 2 long rifles and an ammo box.
Yeah. And you have like it kind of opens at an angle, but you have this sort of clamshell design where it's an L this way and an L that way, so you get a box section for it. I'm gonna try and pull that out, but this is that. Never get my fingers in there.
These fingers don't work.
There you go. This is another cool thing. We're trying to focus on service. So that's your HEPA filter replacement right there. It takes about 2 seconds.
Oh, wow.
So you just unclip those, pull it out, and put one in. You do it right at home.
Okay, let's just, if we can look at the ramp, then that would be great too. Oh, maybe not. I think somebody put a pillar in the way here. No, very good. Huh. Oh, and you got another.
Yeah, we got some underbed storage here.
That's where you put groceries. I mean, really, right?
It's wherever you want it, man.
Actually, the one thing I've always loved about the Model 3 is the Model Y and the Model 3 is the ability to use that in the front as your ice chest. Yeah. So.
Yep. Drain hole in the bottom.
And there you go. See, finally Ford gave you something.
Look, custom Cybertruck logo.
Oh my God. Look at that.
It's one of the few logos on the truck, by the way.
There's no Tesla logo.
There's no Tesla T or
Really?
Tesla badging anywhere on the truck.
You don't need it.
Yeah.
Exactly.
What?
Exactly.
I mean, save
so
the
we
money.
we save the money. We save the weight.
Wowzers. Way cool. Okay, so I just got my head filled to overflowing with information. I'd like to thank all you guys for helping me out. Lars is going to take me on a little inside tour here, but I really appreciate you giving out your time and basically sharing with our audience. This is going to be a brilliant video. So anyway, thank you so much.
You're welcome,
Appreciate
Sandy.
it.
Thanks
Thank
for coming.
Definitely.
Thank you so much.
Nice to meet you.
Yep.
Oh, what fun. What fun. We've gone on for days.
We have.
I had to plug in one of my headphones because it died on me.
Oh.
Yeah. In conclusion, I mean, great stuff. Any closing thoughts you guys wanted to share?
I was just going to say, I really hope that we see the tour that he went on with Lars right after that. I think there's a decent chance that they went to go see that airbending process. And I'm hoping that actually gets to be shared with the public. So that's definitely something we'll have to wait on.
Yeah.
Yes.
Obviously, I hope they expand who gets to see these things in the future because Sandy does great work, but others would bring different perspectives, ask different questions. And I don't know of anyone in the Tesla community who would ask where the shrimp is. And that seemed par for the course for Investor Day. If you watched it, that room was full of the most bored, detached, disinterested, non-experts I've ever seen. And the presentation they were giving was masterful, but they just didn't get it.
This is
Yeah,
our
that was
filet
a shame.
mignon.
What was that, Ken?
This is our filet mignon right here.
Yeah.
We just had it.
Yeah. Yeah. Yeah.
Well, I had a
So-
I can't
blast
wait to.
breaking down all of this with y'all. That's for sure. It's fun to, get to see this type of quality information with other minds that can understand and help us to unpack all of this. And
Yeah. And
especially appreciate your additions, Ken, as well.
Well, thank you.
yeah.
Thanks for,
Thank you,
for
Ken.
having me.
Yeah. We got lucky because when you announced this, Hans, Ken direct messaged me and said, "Wow, I'm looking forward to it." And I said, "I need you, Ken. I need you." And he's like, I'll figure it out. I'll figure something
The
out.
first time ever on YouTube.
Yeah, he's a brand new YouTuber.
Yeah, so
So-
take it easy on me on the comments.
Be nice to Ken. In the comments, what did we miss? What did we misunderstand? I don't know. I feel like we covered a little bit of ground, but there's always more. Like, subscribe, do all the usual things. Head over to Hans C. Nelson's channel on the YouTubes. Find him on the Twitters of X. For everybody else, stay tuned, stay juicy. And I can't wait to hear from you, clever robots. Yes, even Ken and Hans on the next one.